Alright, so this is Mrs. Conway. This is your lesson for May 16th. So today you're going to be looking at using matrix operations to fit a polynomial to any given number of points. So there will be a classwork worksheet that you're going to work through with some guided notes, and then you're going to need to finish that. That will be checked tomorrow. So the first thing that I would like you to do, the sub can pause the video to give you about 5 minutes to work on this warm-up. We want to know how we determine if the point 9, 4 is on the line 4x minus 6y equals 12. So go ahead and pause that video and take about 5 minutes to work on this. Okay, so now how do we determine if a point is on a line? So what we want to do is we want to just basically take the value of 9, which is our x value, and plug it in for x, and then we're going to take our value of 4, which is our y value, and plug it in for y. So I'm going to get 4 times 9 minus 6 times 4, and I want to know if that equals 12. Okay? So 4 times 9, I apologize, that didn't write very clearly, is 36 minus 24. And I want to know, does that equal 12? And in fact, it does. 36 minus 24 is 12. So I now know that yes, 9, 4 is on the line 4x minus 6y equals 12. Okay? Alright, your homework from last night was to complete these word problems and the systems of equations using your inverse matrices. So I'm going to zoom in, and each time I zoom in, if you'd like to check, to pause the video so you can take some time to check, that would be fine. So first of all, in number 1, you get the systems of equations 5f plus 3t equals 40.12 and 2f plus 10t equals 23.88. So when you solve that systems of equations using matrices, you should be using the matrix 5, 3, 2, 10, and multiplying the inverse of that, which is matrix A, times matrix B, which is 40.12, or $40.12, and $23.88. Okay, when you multiply those two matrices together, you will get 749 for your x, or for f in this case, and for your thread you're going to get 89 cents. Okay, so you're going to do the same thing through this whole worksheet. So here's number 2, and again you can pause this as you need to. And number 3. And then on the back with your word problems, you have, again, this was the best to use your, for number 4, it was probably best just to use substitution. So you're going to take this equation and set it equal to this, or excuse me, expression, because they're both equal to c. You end up with 10 fish. And for the last 2, you can see the answers for each of those problems, numbers 5 and 6. Alright, so going up here to your solving systems of equations using matrices, the number of unknowns was just how many variables you had, and then you're going to plug in A inverse B for all of these and solve them. So you do get some decimals with these, or you can use your math enter function to get the fractions if they exist. So again, that's math enter. That will turn your whole matrix into fractions. Okay? Alright, let's go on to our lesson. You can go ahead and hand out the guided note sheet. Alright, again, at any time, if you want to pause this, please feel free to do so. So first of all, we're going to talk about standard form and linear equations. So we're not going to quite get to the quadratics yet, but we will be getting there by the end of class. We're right now just going to focus on linear equations, which are in the form of ax plus b equals y. So again, if you recall that in a linear equation, our coefficient of x is always the slope, and the thing that's by itself, or the constant, is what we call this. is our constant, which is the y-intercept. Now that's not going to matter too much here, because what I'm trying to do is I am trying to figure out basically if I have 2 points, what would be that linear equation. So in this case, I know what my standard form is. In this case, my a is -2 because it's the coefficient of x, and my b value is 19 because it's the constant or the number by itself. Okay? Remember, we don't have to write this, but this is to the first power, and anything to the 0 power is 1, so I really don't have to write that, and I really don't need to write that 1, and that's why it just turns into -2x plus 19. And again, this is a linear equation. And if you remember, how many points does it take to make a line? Well, if I have 1 point, can I get a line? No, I can't. I need at least 2 points in order to determine a line. Okay? So that would be if I had something like this. I know that doesn't go exactly through, but I can move it up here. But I basically need 2 points to determine a line. So what I'm looking for is, if I'm given these 2 points, I'm looking for an equation that will fit, which this is the equation that I'm ultimately trying to get. I'm just trying to get an equation, come on, I'm trying to get the eraser here. Here we go. I'm just trying to get the equation, the linear equation, that would fit those points that I'm given. Okay? And again, for a line, this would actually not be a line that fits this because this is a negative slope. That was just an example. So in this case, if I have 2 coordinates, -3, 4, and 2, -1, and I want to get an equation that looks like this, ax plus b equals y, I'm first going to take my x and y coordinates and I'm going to plug them into that standard form. So whatever my x is, I'm going to plug that in for x. Whatever my y is, I'm going to plug that in for y. And I'm going to be left with the variables a and b. So for example, if I plug in first the point -3, 4, that's basically when x is -3, that will be a times -3 plus b equals 4. And if I just move that to in front, that would be -3a plus b equals 4. For the point 2, -1, again, I'm going to plug in wherever I see an x, I'm going to plug in a 2. And then my y is equal to -1, so I have 2a plus b equals -1. Now, from there, I'm going to create 2 matrices to solve this. Okay? I'm going to take my coefficient -3, 1 and 2, 1, -3, 1, 2, and 1, and then I'm going to take my b, which in this case matrix B is going to be my resultant, which is 4 and -1. 4 and -1, those are my y values basically. And I'm actually going to call these a and b because those are the 2 variables I'm trying to find. I'm trying to find what values for a and b would create a linear equation that fits those 2 points. Okay? Now, notice that little column of 1s here that I have. That should look familiar from finding the area of triangles. I'm now going to solve my matrix using my operations a inverse b. So I'm going to take the inverse of a times b like you've been doing. And then there's actually a little mistake here. This is actually -x plus 1. Okay? And again, so if I were to take and graph that equation, -x plus 1, I would find, and again in that equation my y-intercept is 1, and then I go down 1 over 1, and I could keep doing that. You would notice that the points, the 2 original points that I started with, which were -3, 4, and 2, 1, -3, 4, which would be here, and the point 2, -1, which is here, that would be on that line, and that's ultimately what I'm trying to do. I'm trying to find an equation that will contain both of those points, and in this case I found an equation which was f of x or y. You could either say it either way, y equals -x plus 1 or f of x equals at -x plus 1. And that both of those points are on that line. Okay? Now, quadratic, you can do the same thing here. So a quadratic equation is ax squared plus bx plus c. So again, in this standard form, a is 3, b is -2, and c is 9. Okay, but what if I'm only given 3 coordinates? So in this case, -1, 5, 2, -1, and 3, -3. I want to know what equation would have all 3 of those points contained in what function would have all 3 of those points on it. So again, I'm going to do the same thing. I'm going to plug negative in for 1 for x, and that's going to be a times -1 squared. And again, that's directly from, there's my x, there's my x here, and then my c equals my y, which is 5. So I'm going to do that for each point, and it's going to look something like this. So in the end, I'm going to have these 3 equations that I'm going to solve simultaneously, systems of equations, in order to find what my a, b, and c, or basically what equation would contain all 3 of those points for a quadratic. Remember, it's a parabola. A quadratic is a parabola. Okay? And again, pause this at any time. Form your matrices using coefficients, so 1, -1, 1, 4, 2, 1, 9, 3, 1, and then your B matrix is going to be your results, 5, -1, and 13. So again, on this side, this is what it's going to look like. And again, notice those column of 1s. Again, those should look familiar. And we're actually solving for A, B, and C. Okay? And now we're going to do A inverse B. So your final result is going to be 4x squared minus 6x minus 5. And again, if you were to graph that parabola, and again, this is just a quick sketch, those 3 points that we just talked about would actually be on that parabola. Okay, so you're going to work now in the next couple examples on your own. I'm going to go ahead and put the answers up here so that you can see them. So I would encourage the sub to go ahead and pause and then go ahead and try solving them in between. Alright, so I'm going to reveal the example for example 2. And when you solve that system, you get 3, -2, 4. So I think this one you got some decimals with. So I'm going to have to check that answer. Oops, sorry, I thought I was paused here. Alright, actually that's right. So my function is going to be f of x equals, my a is 3, x squared, minus 2x, that's my b, and then plus 4. Okay, and so then you would see that you get 3x squared minus 2x plus 4. And again, if I were to graph a parabola, those points would be on that parabola. Okay? And then finally, example 3. And this is the one I think you actually get decimals for. I don't think that this is right. Yeah, so for this one, you're actually going to get fractions, and that's okay. You do math enter once you get those decimals after A inverse B. You get -1/24, 1/2, and 85/24. And again, those are the values that you're going to plug into the function. So you can have -1/24 x squared, kind of weird, but still works, plus 1/2 x, and then plus 85/24. Okay? Alright, so you're going to go ahead and finish this worksheet up for homework, and please let me know if you have questions.